Hello, in our last 3 lessons, we have discussed about the increasing, decreasing intervals for a function, local minimum, maximum for a function, and also the vertical, horizontal, and oblique asymptotes. So today we are going to further on the local minimum, maximum. For local minimum, maximum, we know that the slope equals 0, so it may be maximum, maybe minimum. And how to determine its minimum maximum? What we have used is we use f prime. If f prime is slope positive, change it to from left to right is down, is negative, positive to negative, changing the sign, we have a local maximum here. If before is local, this one is the slope is negative, then change it to positive. Then we have a minimum. It is a little bit troublesome. We do have another way to find local minimum or maximum, and that is a concavity. So concavity is open up or down kind of. So this one, if it's like a parabola, you will see this is open down. This one we call concave down, and this U shape is up, so we call it concave up. Concave down, concave up, the difficult part is it's not always U shape. Sometimes you just half of the branch. Then we still call that is concave down. This part concave down, this part concave up, concave up. So that is what we are going to learn today, concave up or concave down. And when it happens, we use a F double prime to find it is concave up or concave down. And also the point of inflection is when the second derivative equals 0 or undefined. And from left to the right side of the f double prime, it doesn't have the concave is changing, then we call it a point of inflection. So point of inflection is f double prime equals 0 or f double prime is undefined, and it changed the concave. This is the concave down. This one is half of this part is up. If it's changing from down to up, then we call it point of inflection. If it doesn't change, then we don't call it point of inflection. Okay. So now we are going to just recall what we have known up to now. So from grade 11 and 12 functions, advanced functions, we know how to find the domain of a function, and we know how to find the discontinuous, a whole removable, and vertical asymptotes, and also any other restrictions for the domain. So this is restrictions for the domain. That is what we know before. Then we also know how to find the x-intercepts by finding the zeros. And also we know how to find the y-intercept by like x equals 0 sub in to find the y value. Also we know how to find the oblique, vertical, horizontal, and oblique asymptotes. Both of them is talking about x approaches positive infinity or negative infinity. So for the vertical asymptotes, it's not and behavior. It's just not x approaches infinity. So the first derivative test, f prime greater than 0 increasing, less than 0 decreasing, and at maximum minimum point f prime equals 0, it may not be the maximum minimum point unless it's changing the sign for the f prime. So this is what we have known before. Then today we are going to discuss about concavity. So these are the several graphs to show you the concave up, concave down. So from A to B, if the graph is this one is negative slope. So this negative slope, this is negative slope. This one seems like the negative slope is steeper. This is negative slope lower. But from -3 to -2, the slope is increasing. So if it's increasing, then the f double prime is a slope of f prime. So this is a slope of the original function is increasing, then f double prime is positive, then we call it concave up. If you put your palm here, it's open up. And same thing here. So this is positive slope. So here is less steeper, here maybe greater steeper. So from 2 to 3 is slope is increasing. So the slope of this f prime is positive. So here is from left side to right side. This is positive, it's steeper. For example, we don't know if 3 or not. We just assume it's bigger. This is a smaller. So from 3 to 2, the slope is decreasing. Then the slope of the slope double prime is negative. Then it's concave down. You put your palm, hold it, your palm is facing down. So this one is negative, this one negative, steeper. So -2 to -3 from left to right is down. Is the slope of slope is negative. So we call both of these two are concave down. So concave down means the slope of f at x decreasing. So not the graph. The graph is increasing. F at x is increasing, but the slope from 3 to 2 is decreasing. So it's concave down. Then it will be the double prime is negative, double prime is positive, then it's open up. Double prime is less than 0, is U-shape down, so it's open down. So this is what we are going to learn of the in this lesson, okay? So now we are going to see the examples. So the conclusion is here. So if the graph is positive 0 is open up, you have a minimum, local minimum. If it's concave down, you have a maximum. So you could just think this is similar with a quadratic. So this is a value, kind of. A greater than 0 open up, a less than 0 open down for quadratic, okay? And you will see why it works, because second derivative of a quadratic is the a value. So point of inflection is where the f double prime equals 0 or undefined, but that one is changes from concave up to concave down. So it's this one. This one is concave down, this is concave up. So it's changing. If both concave down, you have a local maximum minimum. So this one is open up. This one is open down, so it's changing. If both open up, you have a minimum. So at point of inflection, we don't have the local maximum minimum. So this is give it a term that is difference from the relative minimum, relative maximum. So now we are going to see if we are able to find the minimum, maximum, the point of intersection, all those type of stuff from this function, okay? So we are going to find the f prime. So this one we could write it as a fraction exponent, so 1/3. This is 1 to the numerator, the 3 index number to the denominator. Then the derivative is the degree to the front, then degree minus 1. This is our first derivative. Then we are going to find the second derivative. So this one 1/3, then bring the number degree to the front, then degree minus 1, so 5/3. So we will look for the f double prime. Then we let f double prime of x equals 0. We want to solve it. We have 1/3 numerator times numerator, denominator times denominator. Then x to the exponent negative, we flip it to positive, equals 0. We move the 0 to other side. You will see we don't have f prime equals 0. You will see negative 2/9 equals 0. So no zeros. This is not exist. No zeros for f double prime of x, but we do have undefined. So how to find this f double prime undefined is let the denominator equal 0, x 5/3 equals 0. This is a restriction. We solve it. We move the 9 to other side by divided 9. Then we take the 3/5 degrees to both sides to get rid of this exponent. Then we have x to the exponent times numerator, denominator. We have 1 equals 0. So x equals 0 is where the f double prime undefined. Then we want to see if that is a point of inflection or not. So we are going to draw this x-axis, and this is x equals 0, left side, right side. And this time we want to find the double prime. So the double prime, the formula for it is we separate the constant and the variable. So when x less than 0, we take x equals -1, so it doesn't matter. X value is always -2 or 9 is negative. -1 to exponent 5/3 give us negative, and pick +1 here. Sub in is positive, so the whole thing for the f double prime, this is a division. You have 2 negative, divide, give you positive. This is 1 negative, we have negative. This positive, it means it's concave up. This one negative means concave down. So concave up, concave down is kind of like this. Okay, this is up, this is down. And at this point, we don't have the local maximum or minimum. And sorry, this question, it didn't ask you what. Consider this one to find what. I will add a question here to find the point of intersection, okay? Consider this one, find point of inflection. So now from this point we know that we have only one x equals 0, which is f double prime is undefined, and f double prime is changing the sign. So it is the point of inflection. So point inflection, there are two conditions. One is f prime, either 0 or undefined, And the second one, f prime, double prime, need to change the sign. If doesn't change the sign, it means it will be either concave up or concave down. So either concave up or concave down, you will have relative maximum or minimum. Only when the change the sign, so this is double prime is open down, is negative, and this is positive, f double prime. We call it point of inflection. And this one is positive, open up. This one concave down. F double prime is negative. It changes the sign at near this point. We call this is point of inflection. So this is for the example 1. Then we are going to continue practice more. So example 2. So f prime exists, but f double prime doesn't exist. For this case, the C, f at C is not an inflection point. So we go back, we need to find the y value because this is only x value. So this is only x value, the y value is sub in f at x equals, the parent function is cubic root of x. So it is 0. So 0, 0 is point of inflection. Then it's done. Okay, so continue next one. So this is another type of question. The f prime exists, but f double prime doesn't exist. But this one is not a inflection point, so we are going to see why. So we do the f prime 4/3 x to the exponent 1/3, and double prime 4/3 times x to the exponent -2/3. Then we are going to find the zeros for it. It will be 4/9. Move the negative x 2/3 to the denominator. We have 0. Then we solve it. So I will rewrite it. So I will rewrite this one. F double prime equals 4/9. Bring the x to the denominator. Then let this one equal 0. The numerator is not 0, so we don't have zeros. The denominator, when x equals 0, is undefined. So this is a possible point of inflection. Then we need to check the left side, right side of f double prime, x equals 0, to see the left, right is positive or negative. So x less than 0, x greater than 0 is double prime. So double prime, you will see you have x squared here, so it will be always positive. So 4/9 is positive, x 2/3 is positive all the time. So this one, you have positive, positive. As long as the f double prime is not changing the sign, it means it's positive. You just think it's a positive, the quadratic open up, so it's concave up. If it's not changing the sign, then it's not. So it's not an inflection point. The reason if f double prime is positive at both sides. So that is how to determine that is not an inflection point. Then we have another example. We see this one may be an inflection point or not. So f prime brings the degree to the front, then degree take away 1, then double prime 5/3 degree to the front, then degree take V1. So then we solve this one. We have 10 over 9, bring the negative exponent to the denominator equals 0. You will see numerator is 10. We won't have 0, but we do have denominator equals 0. We have x equals 0. So f double prime undefined. So this is a possible point of inflection, and how to determine it is a relative maximum minimum point or point of inflection. We are going to draw the chart. So this is x-axis, this is x equals 0. 1, 0 divided the x-axis to 2 intervals. So this is f double prime. We have factor 10 over 9. And x1 was 3 here. So x less than 0, we take negative 1s. The constant always positive, no change. But this one, negative 1 subbing, have negative. And x greater than 1, we take positive 1 here. 1 cubic third root give us positive. So you will see for this question, the point, the double prime is changing the sign. So if changing the sign, then we know this is a point of inflection, and we have to find the y value for x equals 0. We sub in x equals 0 here. You have 0 to the exponent 5 over 3 give us 0. So 0, 0 point is an inflection point. The reason is the sign is changing. So negative means it's going down. Positive means negative means it's open down. Okay, so open down. Then another one is open up. So it will be open up, then open down. So this is that point. This is open up, down. This is open up. So this is point of inflection. Then we are going to practice another one to find all the point of inflection and also the intervals of concavity. So example 4, we find if we see the point of inflection, we know we are looking for the second derivative. So we find the first derivative first. 3 times 4x to the exponent 3 minus 8 times 3x to the exponent 2 plus 6 times 2x to the exponent 2 minus 1 is 1. Then we find the second derivative of this one. So we could simplify this first. 12x cubed minus 24x squared plus 12x, then double prime, equals 12 times 3x squared minus 24 times 2x to the exponent 1 plus 12 times x to the exponent 0 is 1. So 36x squared minus 48x plus 12. Then we want to find the zeros for the second derivative. So 36x squared minus 48x plus 12 equals 0. 12, 48, 36, we have common factor 12. We take the 12 out, each term divided by 12. Then after that, we want to divide the 12 to both sides. Then we have 3x squared minus 4x plus 1 equals 0. So in order to find the zeros, we want to factor 8. So this one 3x squared minus 4x plus 1. 3x, this is prime number, so we could try it. It's x 3x only. You don't have other ways. X times 3x give you 3x. Then what you have to find is these two numbers times together is 1, and this cross give you -4. So you could find two numbers times together 3, add together -4. We have, so this is from AC times. AC times give you 3, so we have 1 times 3 only, and -1, -3 will add together give you -4. So this cross, one is -1, one is -3. So if we put -1 here, -1 divided by 3 won't give you an integer, so we want to put -3 here. -3 divided by 3 give you -1. So -1 times 3 give you -3. And these two cross times will give you -1. So 1 times a number give you -1 will be -1. Then double check. So x times 3x, 3x squared. -1 times -1 is +1. Cross -3x, -1x give you -4x. So this works. And please go home and practice on factoring the trinomials if you forgot it. So you don't have to use this way. You could use other ways that what you have learned before. We have many ways to do the factoring. So this is a not simple trinomial, it's a complex trinomial factoring. So you have to find two numbers times together equals a times c, I together equals number at front of x, -4. Once you have these two numbers, then they represent the cross. So then each bracket may be 0 to solve for the zeros. So x equals 1, move the -1 to other side, divided by 3, we have x equals 1 over 3. So you have two zeros, and from these two zeros, we want to draw the chart. So two zeros will give us 3 intervals. So this is x equals 1/3, then x equals 1. So two zeros, you have 3 intervals. Between the 1/3 and 1, this is greater than 1, and here we are looking for the f double prime, positive or negative. So we want to use this factor form. So we have 12, then x minus 1, 3x minus 1. So this is a factor of f double prime. And for the positive 12, it doesn't matter what the x value is, it's always positive. And x minus 1, we pick one number, 0 here. 0 minus 1 is negative. 0 minus 1 is negative. So f double prime for this interval is 2 negative divide or multiply give you positive. And 1/3 to 1, we pick the number 2/3. 2/3 minus 1 give you -1. 2/3 times 3 give you 2. 2 minus 1 is positive, so this is negative. X greater than 1, we pick x equals 2. So 2 minus 1 positive. 3 times 2 minus 1 is positive, is positive. And from this chart, you will see at these 2 points, it's changing the sign. So both of them are points of inflection. So this is open up, this is open down, and this is open up again. And we have draw it in the decimals, so you will see. We type in the equation, then it will draw it for you, and this is a kind of like the 1/3 point. So this is open up, this is open down, this is open up again. So this is how it looks like. So open up, this is open down, then this is open up again. So this is the point of intersection. We write the conclusions. So x equals 1 over 3 and x equals 1 will give you the point of inflection. You could sub in the 1/3 to do the calculation and find the y value. Okay, so this one is around 0.3. Sub in from the graph, we could read it. So y value you sub in to the original function is around 0.4, and when x equals 1, the y value is around 1. Okay, they are the point of inflection. Then we do the next one. So first the derivative. This is a u times v, so u prime times v plus u v prime. So u prime is 1. Then copy the second function, then plus x times 1 over 2 x plus 1 to the exponent 1 over 2 minus 1 give you negative 1 over 2. Then chain rule, do the base derivative. So x plus 1 derivative is 1. Then rewrite it. Square root x plus 1 plus x over 2 times x plus 1 to the exponent negative 1 over 2. Then double prime. So this is 1 over 2 x plus 1 to the exponent minus 1 is negative 1 over 2. Then this is u times v again. So derivative of the first one is 1 over 2. Copy the second function, then plus. Copy the first one, the second one derivative x plus 1 to the exponent minus 1. Then base x plus 1 derivative. So this is a double derivative. Then simplify it. We flip all those negative exponent to the denominator. Then minus x over 4. Denominator times denominator. Then this one will be square root x plus 1 to the exponent cubed. So we want to change everything to the same denominator. So this 1 over 2, 1 over 2 together will give you just 1 times 1 over square root x plus 1. Then minus x over 4, 1 over square root x plus 1 cubed. So in order to have the same denominator, we need to times x plus 1 to both top and bottom. Then, and also we need to times 4 to get the same denominator. Then we are going to have equals 4 bracket square root x plus 1 to the exponent cubed. Then 4x plus 4 minus x give us 3x plus 4. We combine the numerator. So this is a double prime, and we want to find the zeros and also the undefined. So the zeros will be just the numerator equals 0. We have x equals negative 4 over 3. And undefined will be the denominator equals 0. So 4 square root. So move the 4 to other side is divide, opposite operation. Then we are going to do the x plus 1 to the exponent 3 over 2 equals 0. Both 2 over 3 exponent. Then these two times give you 1, so x plus 1 equals 0. We have x equals -1. So we have these two possible point of inflection or the maximum minimum. Then we are going to draw the chart. So we have two zeros for the numerator and the denominator. We are going to draw the chart. So this is x-axis, x equals -1, then x equals, 4/3. Which one is smaller? We put it on the left. So we have these two, 1 0 for the numerator, another 0 for the denominator, then f double prime. So this one is x less than -4/3. This is between -4/3 and -1. This is greater than -1. And f double prime, we have numerator is 3x plus 4. Denominator is 4 bracket square root x plus 1 to the exponent q. Then we are going to determine these two factors, positive or negative, in order to determine the f double prime, positive or negative. So x less than -4/3, we pick -2 here. So 3 times -2 plus 4 give us -2 is negative. And the -2 put here is -2 plus 1 is -1. Square root doesn't exist. And from this -4/3 to -1, we pick -1.1. Put here is 3 times -1.1 plus 4 is positive. Then -1.1 put here, -1.1 plus 1 is -0.1. Square root doesn't exist, so it doesn't exist. And when x greater than -1, we pick 0. Put here is positive. Put here is positive. So we have f double prime doesn't exist. And this one is positive, so it's open up. And this one, there's no sign, so no sign for all these intervals, so it means we don't have positive or negative. So this one is no point of intersection for this part, no point of inflection, sorry. And doesn't exist to positive, there's no changing, so there's no changing of the sign, so there's no point of inflection. So the whole question is no point of inflection. So sorry, today's lesson, a lot of writing. Each question is a little bit, answers are long, so a lot of writing. And go back and double check what we did is concavity. So f double prime, positive is open up, negative is open down. Then if is f prime equals 0, so if changing the sign is local maximum or local minimum, if the f double prime is changing from positive or negative, is point of inflection, not the, so this doesn't change the sign, both positive, then here is 0, then is a local maximum or minimum. So if change the sign at the point, this point, we call this point is point of inflection. Point of inflection definition is f double prime equals 0 or and doesn't exist. But at the left side, right side is changing the sign, is point of inflection. If it didn't change the sign, then it will be either concave up or concave down. So thanks for watching. And today's homework is on delta mass 4.4. Thank you.